For the next two lessons, we're going to use the formulas we have to prove things. So these proofs tend to be a bit easier than the other two-column proofs because they're more of a calculate these distances to show things as opposed to memorizing theorems and definitions. So we're going to start off with just remembering our distance formula and our midpoint formula and our slope formula. So take a minute and see if you remember which one's which. And then I'll show you the distance formula is the one with the big square root sign because it's derived from the Pythagorean theorem. And it looks like this, where we have the difference in the x's and then we square that answer, plus the difference in the y's and we square that answer, then we take the square root of the whole thing. The midpoint is the average of the two values. So we take our x's and we add them up and divide by 2. We take our y's and add them up and divide by 2, and that gives us a coordinate. So for both midpoint and distance, the order of the values doesn't matter as long as you are using x's with x's and y's with y's. However, for the slope, the order does matter. It has to be, if you start with y2, you have to start with x2. Otherwise, you'll get the wrong sign. And that's not going to be good. The sign doesn't matter for midpoint because it's addition, and the sign doesn't matter for distance because we're squaring our answer anyway. So these are the three formulas we're going to use. For coordinate geometry proofs, the biggest thing you have to remember, one of the biggest things you have to remember is you have to write a concluding statement. So once you show all your work for your calculations, you have to have a final statement saying, the distances are the same, therefore the triangle is isosceles, blah, 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 blah. If you don't have this concluding statement, you will lose points on the regions, and that's a silly thing to lose points for, so make sure you do that. So we're going to list some ways to prove. We're going to start with the triangles, and if we want to prove a triangle is isosceles, remember an isosceles triangle has two congruent sides. So basically, you have to show that two sides have equal measure. So we use the distance formula to find the lengths of the three sides. And then, if the triangle is isosceles, two of your calculations are going to end up being the same. So all you have to do is have a statement saying these two sides are equal, therefore the triangle is isosceles. To prove a triangle is a right triangle, we can do two different things. We can look at the angles. So if we're going to look at the angles between two sides, we're going to calculate the slopes. So you're going to find the slopes of all three sides using the slope formula. And then you're going to find that two slopes are going to be negative reciprocals. So that means they're going to be perpendicular and therefore a right angle. That's all we need to show that it's a right triangle. Calculate three slopes and then show that two of them are perpendicular to each other. Another way to prove that a triangle is a right triangle is to use the Pythagorean theorem. So you would use the distance formula to find the lengths of the three sides, and then you would use Pythagorean theorem, remembering that the longest side has to be the hypotenuse. So you could prove that triangles are right triangles either way. I think the one with the least amount of work is probably using the slope formula, finding the slope of all three sides. But we're going to work through an example to show you. So we're going to prove triangle sun is an isosceles triangle, and then I'm going to leave it up to you to prove that sun is a right triangle. So to prove sun is an isosceles triangle, I'm going to use the distance formula to find the length of all three sides. Now, usually graphing it is optional, but it's always a good idea to do that. Now make sure you show your work. So I'm going to find the length of SU, and then I'm going to find the length of UN. Oops, I need to write it right. And, oops, I don't need a bar over that if I'm doing distance. And then the length of SN. And I'm going to use the distance formula, and we don't necessarily have to reduce it all the way down. All we have to do is enough work to show that two sides are the same value. So SU, if I look at it, the distance formula, it's going to be 5 minus 2, so that's 3 squared, plus 8 minus 4. and that's 4 squared. 3 squared plus 4 squared. So this is 9 plus 16 under the radical sign. So that's radical 25. UN, if I look at it, UN is going to be 9 minus 5. So that's 4 squared plus 5 minus 8. So that's going to be negative 3 squared. But remember, whenever you square something, it ends up positive. So this is also radical 25. That's enough to show that it's isosceles. I'm going to go ahead and do the third distance because we might need it down below. So SN is going to be 9 minus 2. That is going to be 7 squared plus 5 minus 4. That's 1 squared. So this is 49 plus 1. That's radical 50. So here's what you would say. SU is equal to UN. Therefore, triangle Sun is isosceles. Now, you don't have to do much more work to prove it's a right triangle because you already have the 3 distances. Since you already have that, I would use Pythagorean theorem to show it. So that's up to you to do, and then we're going to go over it in class. Next, we're going to talk about different ways to prove that a quadrilateral is a parallelogram. So a parallelogram has both pairs of opposite sides congruent. That's the first way we're going to do this. So you can use the distance formula to find the lengths of all 4 sides, and then you would just write a statement showing that both pairs of opposite sides are equal. That's the first way to do this. But we can also do this by calculating the 4 slopes. When you calculate the slopes, you can see that you're going to have 2 pairs of slopes that are equal, and that's enough to show that both pairs of opposite sides are parallel, because the opposite sides will have equal slopes. The third way to prove that a quadrilateral is a parallelogram, I think involves the least amount of work, and that's dealing with the diagonals and using the midpoint formula. So if you find the midpoint of both diagonals, if the quadrilateral is a parallelogram, then the midpoints will be the same, and that shows the diagonals bisect each other, and that's sufficient to show that a quadrilateral is a parallelogram. So here I have quadrilateral Park, and I've graphed the coordinates. R is at 9, 1, and K is at 7, negative 2. I want to prove that Park is a parallelogram. Well, the quickest way to do that is to find the midpoint of AK and PR. So the midpoint of AK is going to be the average of the x's and the average of the y's. So it's going to be 3 plus 7 over 2 and 4 plus negative 2 over 2. So the midpoint of AK is going to be, that's 10 divided by 2, so that should be 5 and 1. So now I find the midpoint of PR. And that's going to be 1 plus 9 over 2, and my y's are going to be 1 plus 1 over 2, and again you get 5, 1. So here's my concluding statements. The diagonals share the same midpoint, and therefore they bisect each other. So the diagonals share the same midpoint, therefore bisect each other, and Park is a parallelogram. That's the kind of concluding statement you need. Parallelogram. Okay, you could have also done this by finding the distances. PA, RK, they would be the same, and PK and AR would also be the same. Or you could have done the 4 slopes, either way. But this is the least amount of calculation, so I always like to use the midpoint for parallelograms. Okay, so if we want to prove a quadrilateral is a rectangle, there's a lot of ways you could do it, because there are a lot of ways you could prove the quadrilateral is a parallelogram. However, I want to show you the most efficient way to do this, because a rectangle is a parallelogram with one right angle. So basically, you can find the slopes of all four sides. That's enough to prove the quadrilateral is a parallelogram, so you need a concluding statement for that part. You need a statement to say that it's a parallelogram. But now, since you have all four slopes, because you're going to find the slopes, you're going to show that opposite sides are parallel, all you have to do is write one more statement, and you're going to show that one pair of consecutive slopes are negative reciprocals. So when you show that a pair of consecutive slopes, those are the slopes that are right next to each other, if they are negative reciprocals, that means the two lines are perpendicular and you have a right angle. So you would then write your concluding statement that you proved it's a rectangle because it's a parallelogram with one right angle. So that's the most efficient way to prove that a quadrilateral is a rectangle. Find the slopes of all four sides, write a statement saying it's a parallelogram because you got opposite sides parallel, and write your second statement that's saying that you have a pair of consecutive slopes that are negative reciprocals and therefore perpendicular. Okay, for this example we have quadrilateral warm, and we have coordinates of WA, and R is at 4, 3, and M is at 2, 5. So I've plotted the points. Again, that's not a requirement, but it's good to graph them so you can take a look at it. I want to prove that warm's a rectangle, and the most efficient way to do that is to calculate four slopes. So the slope of WM is going to be, I have W and I have M, 5 minus 1 over 2 minus a negative 2. So that slope is going to be 4 over 4, which is a slope of 1. We could just leave it like that. That's going to be, actually, if you have a fraction, it's probably best if you reduce it because you might not have the same numbers each time until they're reduced. So there's a slope of WM. Then we have the slope of WA. So that's going to be W again, and now A, so negative 1 minus 1 over 0 minus negative 2, and that ends up being negative 1. The slope of AR is going to be 3 minus a negative 1 over 4 minus 0, which is 4 over 4. So again, that's 1. And the slope of RM is the last one. And that's going to be 5 minus 3 over 2 minus 4. So that's 2 over negative 2, so that's negative 1. This is enough information to make our concluding statements. The first thing we say is opposite sides are parallel, therefore warm is a parallelogram. So both pairs of opposite sides are parallel, therefore warm is a parallelogram. Incidentally, the three dots stand for therefore. Therefore warm is a parallelogram. And now we say consecutive sides are perpendicular because they are negative reciprocals. Therefore warm is a rectangle. So we write it out, consecutive sides are perpendicular, therefore warm is a rectangle. So all we had to do to prove it was calculate the four slopes. Again, that's the most efficient way to prove that something is a rectangle.